This is a piece of paper. It has a hole in it. I don't know where that hole came from. I think that hole came from when I dropped the wrench on top of it. See this line that goes through this point right here? Of course you don't see it because I haven't made it yet. Hold on 1 second. I'm going to fold this thing in half. There we go. And I take a pen. Excuse me. And I draw a line down the middle. This line is a line of symmetry because the paper is symmetric about this line. If I fold this in half, it will come on top of each other. In fact, I found the line of symmetry by folding it in half and drawing a line. If I fold it in half another way, actually let's go this way. Yeah, let's do it. There you go. This new line right here, this one going up and down, that's a line of symmetry. I've got another way to fold it in half. I can do it this way. Not very well, but I can do it that way. Let's see, this one. That. There we go. All right. There we go. One more line of symmetry. See that diagonal line that's going through here? Now, did I fold the paper in half? Well, technically, yes, I did. Because if I were to cut down that diagonal line, I don't have a scissors, but let's just try. Just kind of do one of these. And nick it. Put it up against here. And break it. Let's start it off with that. There we go. Come on, baby. Oh, almost. Almost. Don't bow on me now. Oh no. Alright, there we go. If I were to cut that in half, I can't really fold this on top of itself to make two symmetric pieces. They aren't symmetric. Now, I could fold it and turn it over and all that kind of stuff, but that's getting into different kind of symmetry that we're not worried about. Alright, let's talk about a few isosceles triangles. Let's see. This right here is an isosceles triangle. It's not a very good one, but it's an isosceles nonetheless. The reason why it's an isosceles is because it has two sides. Well, it's got three sides, which makes it a triangle in the first place. But two of those sides, this one and that one, those are the same size. So because those are the same size, you have two sides of equal length. It's called an isosceles triangle. An isosceles triangle has a line of symmetry. You can go draw one straight up and down there. This triangle right here, this is called an equilateral triangle, or at least the best I could do. This says that this length is the same as that length, which is the same as that length. Technically, an equilateral triangle is an isosceles triangle, just a very special one. It's special because not only does it have at least two equal sides, it's got all three equal sides. Just like how a square is the same as is really a rectangle with an extra feature. This also has the line of symmetry. Now, I wanted to tell you about some right triangles. Now, the right triangles is a right triangle looks like this. And we usually put a little box at the corner right there. That's signifying that that's a 90-degree angle. this is a right triangle because at least or only one of its angles is 90 degrees. I was going to say at least one of its angles is 90 degrees. But if more than one of its angles were 90 degrees, then it wouldn't be a triangle anymore. Anyway, you can't really draw any lines of symmetry on this one. However, if I drew this one like this, maybe, then I could draw a line of symmetry that looks like this. If, of course, this length right here were equal to this length right here. I'm putting these weird markings on them to show you that this is the same as that, this is the same as that, and these two are the same. But then again, this is really just an isosceles triangle flipped over to the side. A very special isosceles triangle, that is. But if you had a triangle that looks like this, where that's a right angle over there, that's not necessarily an equilateral, or that's not necessarily a symmetric triangle. It doesn't have a line of symmetry. This shape right here is called a parallelogram. It's called a parallelogram is because it has four sides, but really the key part of being a parallelogram is this side right here is parallel to that side right there. Just like this side right here is parallel to that side right there. The question is this dotted line a line of symmetry? And the answer is, I'm waiting for you to give the answer. Yes or no? No. If I cut this here, or maybe not cut this, but I fold it right here, I can't really make those equal. This right here is a very special parallelogram. See, it still is a parallelogram, only the difference between this one and this one is all of these sides are the same length. If this were like 2 inches, 2 inches, 2 inches, and 2 inches, or something like it. Now, how can I draw a line so that it's symmetric? Well, I could fold it this way. If that's the case, is that symmetric? A line of symmetry? And the answer would be yes. Wait, let me think about it. Yes. Yeah, all right. Same thing as if I were to draw a line this way. Erase this one. That's a line of symmetry. I guess if you kind of think about it, a rhombus is also known as a diamond. And all I did was I drew this line or that line. And those are totally symmetric about those two lines. All right. This right here is called a trapezoid. Now, a trapezoid has some features of a parallelogram in that it has two parts that are parallel, but the other two parts aren't. So it's not a parallelogram, it's a trapezoid. If I draw this dotted line right here, that's the line of symmetry. Now if I move that line a little bit off to the side, this is no longer the line of symmetry because this side can't fold over and make that side. It's kind of like a butterfly. A butterfly is totally symmetric about itself. All right, here's my question for you. Is this symmetric? I'm going to draw these pictures. Now, I granted that my drawing is ugly. Use your imagination and pretend I'm actually good at drawing. There we go. All right. So, is that a line of symmetry? I would say yes. Is this a line of symmetry? Okay. What did they do? They did this. Is this a line of symmetry? And is this a line of symmetry? Yes. 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 No. But if I redrew this to be here, then yes. Or if I redrew this to be here, or here, or here, or here. Yeah, All of those are lines of symmetries. But if you gave me that funky one like this, then the answer's not.